Okay, 11.3. We're going to talk about the graphs of these polynomials. It asks you to graph this one. You can do a lot of this on your calculator. So go to y equals and enter your equation. It's x to the third plus 6x squared minus x minus 6. And then I want you to press the window feature. And we're going to set the window. I've already set it up for this problem. The x minimum is negative 10. The x maximum is 10. The y minimum is negative 175. And the y max is 175. And the x scale is 1 and the y scale is 1. It's fine if you leave it like that. It's not going to make any difference. We're going to be able to graph it and get our answer. So our answer is A. That's the one that it matches. So you can put that in there and you can graph it and you can get those answers. Question 4 is the next one we're going to do, and it's y equals 3x to the fourth. And then I want to set my window. My window looks like the x minimum is negative 4, and the x maximum is 4, and the y minimum is negative 20, and the y maximum is 20. And so I'm going to graph it, and we're going to see which picture we like. There it is. It's answer choice D. And then it goes on to say, determine the interval of the domain for which the function's increasing. It's increasing from here all the way, that's from 0 to positive infinity. And it's decreasing from negative infinity all the way to 0. Question 5 says the x-intercepts of a function y equals f of x are the real solutions of the equation, and that's true. The graph and the equation are tied together, and those solutions of the equation are the x-intercepts of the graph. Question 6 says if g of 5 equals 0, what point is on the graph of g? Well, that would be x is 5, y is 0. So for number 6, the first answer is 5, 0, and the corresponding x-intercept is 5. For the function, find the maximum number of real zeros. That is its highest exponent. So it has 7 is its maximum. It might not have 7, but that's the maximum that it can have. The maximum number of x-intercepts. Well, they're connected. It's the same thing, and there will be 7 of those. And then the maximum number of turning points. Well, that's always going to be 1 less than that leading coefficient. So that's going to be 6. I said 1 less than the leading coefficient. I meant 1 less than the highest power. Let's look at number 8. Number 8 says, find the maximum number of real zeros. Well, the highest power here is 6, so it could have 6 real zeros. How many x-intercepts can it have? 6. And what about the number of turning points? Well, that would be 1 less, so it would be 5. Okay, here's question 9. It says the graph and the degree of the polynomial with real coefficients are given below. It's degree 3. I only see one place it crosses the x-axis, but it's degree 3, so let's keep reading. Determine the number of real zeros and the number of non-real complex zeros. Assume all the zeros are distinct. So nothing's used twice, that's what they're saying. So this is going to be answer choice C, which says each distinct real zero corresponds to an x-intercept. Non-real complex imaginary zeros do not correspond to x-intercepts. So this problem has 1 real zero and 2 imaginary zeros for a total of 3. Question 10. How many real zeros does this function have? Count them. 1, 2, 3. It has 3. Question 11, how many real zeros are there? There are 2 imaginary zeros. It doesn't touch the x-axis. So it would have 2 imaginary zeros. Number 12, the graph is degree 3. I see one place that it crosses, so 1 real and 2 imaginary. And that is answer choice A. The next one we're going to do is 16. It says Here's a polynomial function. How many negative real zeros does it have? Well, it has 1, 2, 3 zeros. One of them is negative, so it only has 1. Okay, question 19 says we have a degree 3 and it has turning points at negative 210 and 1 negative 17. So let's look at how these are set up. The x-axis is counting ones, the y is counting by 5s. So at negative 2, oh no, that's not at 10, so it's not this one. This is negative 1, 10. This has a turning point at negative 2, 10. Let's check the other one out. Positive 1, negative 17. Okay, that one might work because this one won't work. So our answer here is C. Determine the maximum number of turning points of this graph. Well, it's 1 less than the highest power, so it is 2. Okay, 21 says the graph of the function has more than one turning point. Use your graphing calculator to find the coordinates of the turning point on the given intervals. So I'm going to start by putting the equation in y equals. I'm going to graph that equation. We see that it has a turning point here and a turning point here. They want us to focus on the turning point that's between negative 1 and 0. So it's that one right there. So you're going to press second and calc or trace. And you wanted to find that's a relative maximum. In that little area, that's the highest point. So we're going to tell it to calculate a maximum. And it's going to ask me the left boundary, and that's where I want negative 1. So I'm going to scoot over until I get to negative 1, or as close to it as I can. And then I'm going to go over until I get to 0. And then I'm just going to hit enter for guess. And there it tells me. It says type an integer or decimal, round to the nearest hundredth. So this is negative 0.08. And the y value is going to be 1.04.